Wasabi, you guys. Welcome to Integration Bee Training for Intermediates Part 16. In this section, we will be learning square-square technique, a very important integration bee trick that you must know, especially when you're going into competitive integration bees like Caltech Harvey Mudd, Carnegie Mellon, or Harvard MIT. Square-square technique is very useful and it is a must-know if you're going to compete in very competitive integration bees. So what is the square-square technique, and why is it so useful? Why is it so important in speed integration? So let me show you the concept first. Okay. So I want you to understand that the square of this, the square of x minus 1 over x, this is equal to x squared plus 2. I'm sorry, not plus 2. That's a minus. Minus 2 plus 1 over x squared. Okay? I mean, I'm assuming you know this identity, right? X squared plus 2xy plus y squared. Notice that this times this is equal to 1. So that's why we just only get 2. Okay? We only get 2. And then the same thing for x plus 1 over x squared. This is x squared plus 2 plus 1 over x squared. Okay? So why is this concept so important in integration bee? The reason is because people can manipulate using this. And it's kind of like, if you remember our previous video with 1 plus sine 2x trick, where we can utilize our du to either, it could be 1 minus sine 2x or 1 plus sine 2x. This is like that. So this can help us determine either we're going to use this or we're going to use this, right? So it's exactly like 1 plus sine 2x trick, depending on our du, right? Depending on our du, we might have just this somewhere in the denominator, but our du can have something, the derivative of one of these. Okay? And speaking about that, let's talk about our derivatives here. So the derivative, you must know these and recognize these by heart. The derivative of 1 over x minus 1 over x. This is 1 plus 1 over x squared. The derivative of x plus 1 over x is 1 minus 1 over x squared. Okay? Just by power rule. So, recognize these. Recognize these by heart. Okay? Alright, now that you understand what all of this stuff is, just these 4 things, let's go ahead and dive into our first integral. Okay, so you probably have seen this integral before, somewhere. And that bound at the top, that's a golden ratio. So that's phi. So I see this is a nasty integral to do partial fractions. It's irreducible. It's you can't factor it. And you know, what do we even do here? Well, first of all, what I see is a bunch of squares. Notice that I see a bunch of squares here. So because I see a bunch of squares, we're going to use the square-square technique. So how do we use the square-square technique? It's similar to undertow, but it's actually a lot easier than undertow. And that is, whenever you see a bunch of squares, divide everything by x squared. Divide everything by x squared. Even if we have ones or constants, divide everything by x squared. Okay. So then we have 1 over 1 plus 1 over x squared. This looks familiar. X squared minus 1 plus 1 over x squared. And notice that we have an x squared and a 1 over x squared. So now, if you remember our previous video, our 1 plus sine 2x trick, that's exactly how we're gonna sort of do the substitution. Our du, we want our du to be 1 plus 1 over x squared. So what does that mean? It means that we want our u to be what? X minus 1 over x. Okay? And so now it's just like the sine 2x plus 1 trick. So here we want x minus 1 over x squared, and that means that we need a minus 2. So we do a minus 2 plus 2 in the denominator, and this will give us x squared plus 1 over x squared, and we want a minus 2. And now that we use this minus 2 here, our leftover would be plus 2 minus 1. That's 1. Okay, and then now this whole thing is x minus 1 over x squared. And our derivative is on top. Awesome. Now we can do our u substitution. Let u equal x minus 1 over x. We get phi minus 1 over phi. This is actually 0 minus 1 over 0. That's negative infinity. And we get du u squared plus 1. Oh, wow. That's amazing. This ugly integral becomes an easy integral. This is just inverse tangent of u. We have negative infinity. And then this here, this is, what is this? Phi minus 1 over phi. I know you can simplify this. If I remember, it was like this? I think that's what it is. So this is equal to phi plus 1. Phi is equal to 1 plus 1 over phi. I don't know why I wrote it like that. 1 over phi. Okay, so this whole thing is equal to 1. Awesome. I forgot what this equals, so I needed to do this. Okay. So this is equal to 1. And so now we plug it in. This is equal to inverse tangent of 1, that's pi over 4. Pi over 4 minus negative pi over 2. And pi over 4 plus pi over 2. This is what? 2 times 2. 3 pi over 4. And there you go. So this integral is from Spivak's calculus textbook. And this looks nasty. Right? If you don't know what you're doing, rest in peace to those students who are just doing their calculus homework and they're given this integral, and that's, oh god. Rest in peace to those students who had to take the long way route of u substitution. But in speed integration, we want to find the fastest solution here. And the fastest trick is the square-square technique. So let's go ahead and apply the square-square technique. Now, why am I using square-square? Because everything is in x squares. If you notice, everything is in x squared. So there's so many squares. I want to divide everything by x squared. So let's go ahead. 1 minus x squared here. We have 1 plus 1 over x squared here. And here, what do we do with this? What do we do with this? Well, here we can take out x squared. We can take out x squared. And so we get 1 over x squared plus x squared here. And this x squared can just come out, right? So now we get 1 minus x squared dx, put a parentheses, 1 plus 1 over x squared x, and then we have x squared plus 1 over x squared. This x is just hanging. What do we do with this? what do we do with this x? This x is just hanging. So what is this? This is weird. Well, let's see what kind of u-sub do we need, and that is where we use our du. So we want our du to equal to 1 minus 1 over x squared. Then our u is what? This is x plus 1 over x. Ah, so this is what we need, x plus 1 over x. Oh, and would you look at this? Maybe that's what x is for. This is to make this x plus 1 over x. Got it. Okay, so now we know this is x plus 1 over x. And here, we need this to be some sort of x plus 1 over x. So we need a plus 2 minus 2. And this will give us x plus 1 over x squared minus 2. Cool. Let u equal x plus 1 over x. Deal. This is equal to du of u square root of u squared minus 2. Ah. It's a trig sub. Let u equal root 2 of secant theta. So then this becomes root 2 secant theta tangent theta d theta. And then this is root 2 secant theta. And then we purposely made this factor out root 2 tangent theta. Oh wow, this is 1 over root 2. So it's theta over root 2. And this is equal to, what does theta equal? U over root 2 inverse secant of this. Okay. And what is our u? X plus 1 over x over root 2 plus c. And that is our answer. This, again, a bunch of x squares. The first thing I would think about is the square-square technique. So, alright, let's start dividing everything by x squared. And I get x squared plus 1 over x squared. Oh wow, this is very easy. Let du, I want my du to be 1 plus 1 over x squared. So that means I'm looking for x minus 1 over x. So that's what I need this for. Alright, so to make this happen, I need minus 2 and then plus 2. So then I get x minus 1 over x squared and then plus 2. So now this is just du of u squared plus 2. Okay? So now this is very easy. This is just 1 over root 2 inverse tangent of x minus 1 over x over root 2 plus c. That's my answer. This looks weird. What do we do here? Well, I want to take out the x squared here. So maybe the x squared becomes square root of x squared, which gives me an x squared outside. Let's try it. So x. So we have x squared now. So now this becomes 1 over x squared plus x squared. Ah, and then I can use this, divide everything by x squared, and I get this. 1 plus 1 over x squared. Ah, so that's my du here. So if I want my du to be 1 plus 1 over x squared, u is equal to x minus 1 over x. Okay, so I need a minus 2 plus 2. So now my u substitution is du square root of u squared. I need a minus 2 plus 2. Okay. Here I would just use inverse tan, not inverse tangent, inverse sinh. So let u equal root 2 of sinh theta. Then This will give me root 2 of cosh theta, d theta, and then root 2, this will give me, yeah, everything cancels out. This is theta, so theta is equal to, is it really just, wait, am I missing something? Root 2, I factor this out. Is that all it is? I feel like I'm missing something. If I do root 2, then my du is root 2 over, root 2 cosh theta, d theta. And then here, I factor out the 2, and I get cosh theta. Wow, so it's just theta. Okay, wow. Inverse sinh of u over 2, and u is x minus 1 over x. Okay. I thought usually there's like this, but I guess not. So there you go. Okay. So I see we have a square here. I'll just immediately go like this. Right? This is x squared plus 1 over x squared plus 2. Okay. But what now? We don't have anything in the numerator. So what are we going to do? We're going to use that very hard to see sneaky trick that we used in our previous video, the 1 plus sine 2x trick, where I'm going to do a half and a 2. And what's going to happen is I'm going to use that 2 as 1 plus 1, 1 plus 1 over x minus 1 over x, because this can be changed in 2 different ways. So I'm going to take advantage of that. So that's what I'm going to do. It's very similar to the 1 plus sine 2x trick. Okay. I'm just going to go like that. Okay. Oh crap. Black pen. Okay. So now we go ahead and separate it. I want this to be 1 over x squared. 1 minus 1 over x squared. Okay? So that means here I need x minus 1 over x squared, but that requires me to have a minus 2. So that's a minus 2 plus 2. It's plus 4. And then here I need a x plus 1 over x squared. So, oh, well, I mean, that's already what we have. So, okay, cool. So now we go ahead and do our u-substitution. U here is du, not u. Du, u squared plus 4. And then here we have 0 to infinity. Oh, wait a minute. Let's rewind. What is our bound? Infinity here, plug in infinity here, we get infinity, plug in 0 here. The right hand side of 0, this becomes negative infinity. Alright, this is the right hand side of 0. Plug in infinity here, it's infinity. Plug in 0 here, the right hand side of 0, that's also positive infinity. Infinity to infinity. 0! You might get triggered. If you're a real analysis and you whatever, you'll get triggered by this. But you see, this is integration B. So, no time for explanation. So that's all 0. Okay. So now, this is equal to 2. Well, I'll put a half there. This is 1 over root 4, which is still a half. Inverse tangent of u over 2 negative, from negative infinity to infinity. This becomes, well, we could put 1/4 here. But if we plug in infinity to a negative infinity, if you plug in infinity minus the negative infinity version of this, this becomes pi. So this whole integral becomes pi over 4. Okay? Okay. This, again, there's a bunch of squares. So I'm gonna divide everything by x squared. That is not correct. 1 over x squared minus 1. And then here, divide everything by x squared. Now, inside this radical, I want to divide everything by x squared. So factoring x squared out, I get 1 over x squared plus 1 plus x squared. Okay, so this will soon become x. And what is this? What is this? So I prefer it to be 1 minus 1 over x squared. So of course we're gonna have to take a negative out for that. So 1 minus 1 over x squared, that means my u needs to be x plus 1 over x. Okay, so with negative 1 minus this, so I need x plus 1 over x. Oh, okay. Well, maybe that's what this is for. Cool. So dx, take that x in there, get x plus 1 over x. And then here, I need a plus 2 minus 2. So I get a plus 2 to make this. And then minus 2, 1 minus 2, that's minus 1. Okay. So now my du, this is negative du over u squared minus, oh, look at this. This is just negative inverse secant of u, x plus 1 over x, plus c. And that is my answer. Oh, finally. About time we deal with this annoying integral here. So, what do? Well, we do the square technique. We get 1 over x squared dx, and then we have x squared plus 1 over x squared. But now what? What do? We use that sneaky little trick, times 2.5. Now, what we can do is we can use half x squared minus negative half square, 1 over x squared. Alright, and now this gives us 1 minus 1, right? Ah, this works out. You see what I did there? This works out. Again, this is a very difficult transition to see, but now that you are aware of this trick, you might utilize this. Okay, so now I need this to be x minus 1 over x squared and x plus 1 over x squared. But what's left over, right? For here, well, our original denominator was this. For this, I need minus 2 plus 2. Here, I need a plus 2 minus 2. Okay, so now we have a half of du u squared plus 2 minus a half of dw w squared minus 2. And this is all equal to, let's see, root 2 of inverse tangent of u, which was x minus 1 over x, over root 2. And then here, the negative kind of cancels out for the inverse tangent. So we get half of 2 over root 2 inverse tangent of x plus 1 over x over root 2 plus c. And that is our answer. So, what do we do here? This is a very weird trig integral. How do we handle this? Well, what if we do secant for here, and then we get 1 plus tan for here. Then we can get from 0 to 2 pi. We have secant square, 1 plus tangent square. I see where this is going. My handwriting is getting bad as I... Okay. So let u equal tangent x. Wait a minute. Hold on. Hold up. This only goes up to pi over 2. So we're going to have to split this from 0 to pi over 2. Okay. From 0 to pi over 2. And then from pi over 2, the left hand side, well, I'm sorry, no, the right hand side of pi over 2 to 3 pi over 2, and then 3 pi over 2 to 2 pi. Okay? Alright, because you have to understand the graph goes like this. Right, this is the graph of tangent x. And we have like let's say that this is 0 here. Then this is like pi, negative pi over 2, and then another pi over 2, 3 pi over 2. There's an asymptote here. So we have to sort of be aware of this. Okay? So now that we got that out of the way, I see that now we have, let's see, plug in 0, so to infinity, we get 1 plus u squared, 1 plus u to the power 4 du. Okay, here, the right hand side of pi over 2 is negative infinity. Alright, if you think about it, this is pi over 2. Right, this is what the tangent graph looks like. Pi over 2, it goes to infinity, but at the right side of pi over 2, it's negative infinity. Alright? Be very careful. Be very, very careful. 3 pi over 2. 3 pi over 2, that's infinity. And then here, negative infinity to 2 pi. What's tangent of 2 pi? Well, 3 pi is like here. 3 pi over 2. And then 2 pi is right here. I guess the easiest way to say this, the easiest way to look at this is what's sine 2 pi, cosine 2 pi? Is 0. Okay, so that's how you go with that. So now what is this? Oh, it's the same integral, right? It's the same integral as this. Same integral as this. It's the same function, except the bounds are different. But because these are the same functions, we can add this to this, and this becomes negative infinity to infinity. Oh, so this is equal to 2 times negative infinity to infinity of 1 plus u squared, 1 plus u4 du. Okay, you can add integrals like that as long as it's the same function. It's the same function, same function, same function, different bounds. Well, 0 to infinity, negative infinity to 0, we can add these two, which becomes negative infinity to infinity. We also have another negative infinity to infinity, so that gives us 2 times this. Okay, that was a lot to take in. That was a lot to take in. But now that we are aware of that, okay, you have to be very, very careful with your bounds. Be very careful with your bounds. This is no joke. Integration bees will trick you with this. Okay, everything's even. So I'm just going to go like this. And I'm going to do square square technique. So 1 over u square plus 1, and then you get u square plus 1 over u square. I should probably rearrange this as well. As you can see, my du is this. So now I want if I want dw to be 1 plus 1 over u square, I want u minus 1 over u. So this becomes 4 here. So I want, this becomes u minus 1 over u square. I need a minus 2 plus 2. So this is w square plus 2 dw. Holy hell. So now, plug in 0, I get negative infinity. Plug in infinity, it's still infinity. So now this is 4 root 2 inverse tangent w root 2 from infinity to negative infinity. This whole thing becomes pi. So now I get 4 pi over root 2. Or I guess you can say 2 root 2 pi as well. There you have it. That's the square square technique. Definitely get comfortable with it. You must get comfortable with this technique. This will appear a lot in integration bees. So again, just like usual, just replay this video and try the problems yourself and try to recall the techniques and tricks. Alright, thank you so much for watching. I hope this helps, and I'll see you guys in the next section.